This is a grade 11 pre-calculus lesson on unit circle. We are going to address 3 competencies here. Competency number 1, illustrate the unit circle. When we say unit circle, the radius is 1 unit. So this is our circle. This is the x-axis, and this is our y-axis. So this is our origin. So from the origin to this point is 1 unit. So the coordinates here are 1, 0. And from the origin to this point here is also 1 unit. So the coordinates of this point here are -1, 0. And from this origin again to this point is equal to 1 unit. So the coordinates of this point here are 0 and 1. And also from the origin to this point is 1 unit. So the coordinates here are 0 and -1. So this one here is a right angle, so that means it's 90 degrees. So from here to here is 1/2 of a circle, that's 180 degrees. Then from here to here is 270 degrees. And then 1 complete revolution, that's 360 degrees. Now, if we are going to divide the 90-degree angle into 2, so this is a 45-degree angle. From here to here is 135 degrees. So from here to here is 225 degrees. And from here to here is 315 degrees. So one of the most important things that we have to know if we study unit circle is finding the coordinates of the terminal point. So what will be the coordinates of the point here? So if we are going to drop a vertical line from this point to the x-axis, so that means this angle here measures 90 degrees, so therefore this angle here measures 45 degrees. Now we have a special right triangle, a 45, 45, 90 right triangle. From our geometry, if our hypotenuse measures 1 unit, the 2 other sides are equal, and their measures are square root of 2 over 2 and square root of 2 over 2. So this means this side here measures square root of 2 over 2, and this side also here measures square root of 2 over 2. So these coordinates here will help us determine the coordinates of the terminal points here, here, and here. And because this terminal point is on the left side of the y-axis and above the x-axis, the coordinates here are negative square root of 2 over 2 and square root of 2 over 2. And here, because this terminal point is below the x-axis and to the left of the y-axis, the coordinates here are negative square root of 2 over 2 and negative square root of 2 over 2. And here, because it's below the x-axis and to the right of the y-axis, the coordinates here are square root of 2 over 2 and negative square root of 2 over 2. Now, if we are going to divide the 90-degree angle into 3, that means it's 30 degrees. Now, what will be the coordinates of the terminal point here? Again, if we are going to drop a line from this point to the x-axis, so this angle here measures 90 degrees, so that means this angle here measures 60 degrees. Now we have another special right triangle, that's a 30, 60, 90 right triangle. And from our geometry, if our hypotenuse is 1 unit, the shortest side measures 1/2, and the longer side measures square root of 3 over 2. So that means this side here, the x, is equal to square root of 3 over 2, and this side here, the y, measures 1 over 2. So these are our coordinates. How about if our angle measures 60 degrees? So again, if we are going to drop a line from this point to the x-axis, we have a 90-degree angle here, and that means this angle measures 30 degrees. We still have a special right triangle, a 30, 60, 90 right triangle. Now this side here is shorter, so this is the x side, which is 1/2, and this side here is longer, this is the y, that is square root of 3 over 2. So therefore the coordinates of this terminal point here are 1/2 and square root of 3 over 2. Now these coordinates here will help us determine the coordinates of the terminal points that are multiples of 30 degrees and 60 degrees. So for 120 degrees, the coordinates are negative 1/2 and square root of 3 over 2. So we have the same values here, except that the x here is negative because it is on the left side of the y-axis. Now if the angle measures 150 degrees, the coordinates of the terminal point are negative square root of 3 over 2 and 1/2. So just like these values again, the only difference is that the value of x is negative because it is on the left side of the y-axis. How about the coordinates of the terminal point here? It's 210 degrees. They have the same values with this, except that our y is negative because it's below the x-axis. So the coordinates are negative square root of 3 over 2 and negative 1 over 2. How about if our terminal point is somewhere here? That's 240 degrees. So the coordinates are negative 1/2 and negative square root of 3 over 2. How about if the terminal point is here? So that's 300 degrees. The coordinates are the same with this, except that the value of y is negative because it's below the x-axis. So the coordinates are 1/2 and negative square root of 3 over 2. And how about if our terminal point is here? That's 330 degrees. So the coordinates are square root of 3 over 2 and negative 1 over 2. Competency number 2. Convert between degree measure and radian measure. We know that this is 90 degrees, and for radian measure, it's pi over 2. And we know also that from here to here is 180 degrees. In radian measure, that's pi. And we know that from here to here, it's 270 degrees. And for radian measure, that's 3 pi over 2. And one complete revolution, which is 360 degrees, that's equal to 2 pi. How about 45 degrees? What will be the equivalent radian measure? So if we divide pi over 2 by 2, so it's pi over 4. Pi over 4 plus pi over 4 is pi over 2. Pi over 2 plus pi over 4 is 3 pi over 4. 3 pi over 4 plus pi over 4, that's 4 pi over 4 or pi. And pi plus pi over 4 equals 5 pi over 4. 5 pi over 4 plus pi over 4 is 3 pi over 2. 3 pi over 2 plus pi over 4 equals 7 pi over 4. How about if it is 30 degrees? So if you are going to divide pi over 2 by 3, it's pi over 6. Now pi over 6 plus pi over 6 equals pi over 3. Pi over 3 plus pi over 6 equals pi over 2. Pi over 2 plus pi over 6 equals 2 pi over 3. 2 pi over 3 plus pi over 6 equals 5 pi over 6. And 5 pi over 6 plus pi over 6 equals pi. Pi plus pi over 6 equals 7 pi over 6. Then 7 pi over 6 plus pi over 6 is 4 pi over 3. 4 pi over 3 plus pi over 6 equals 3 pi over 2. 3 pi over 2 plus pi over 6 equals 5 pi over 3. And 5 pi over 3 plus pi over 6 equals 11 pi over 6. How about if our angles don't fall on the multiples of 45 degrees or 30 degrees? Example number 1. Convert 35 degrees to radian measure. All we have to do here is multiply 35 degrees by pi over 180 degrees. Here degrees cancel out, and if we are going to simplify this, this will give us 7 pi over 36 radians. Example number 2. Convert 160 degrees to radian measure. Again, we will just multiply it by pi over 180 degrees. So degrees cancel out, and then if we are going to simplify this, this will give us 8 pi over 9 radians. Example number 3. Convert 5 pi over 12 to degree measure. So if we are going to convert a radian measure to degree measure, we will just multiply it by 180 degrees over pi. So here, pi cancels out, and if we are going to simplify this, this will give us 75 degrees. Example number 4. Convert 11 pi over 15 to degree measure. So again, we will just multiply this radian measure by 180 degrees over pi. So pi cancels out, and then if we are going to simplify this, this will give us 132 degrees. Competency number 3. Illustrate angles in standard position and coterminal. So angles are in standard position if its vertex is on the origin. So the vertex is here, and one of its rays is on the positive side of x. So here. Now let's do an example. Draw 210 degrees in standard form. So the vertex should be here, one of the rays should be here, and then 210 degrees. So from here to here is 180, so that means 30 more. So this is our angle, 210 degrees. Example number 6. Draw negative 120 degrees in standard form. So our vertex is here, one of the rays is here, and then because it's negative, we move clockwise. So from here to here is 90 degrees, and we need 30 more. So this is the angle, negative 120 degrees. Example number 7. Find a coterminal angle between 0 degrees and 360 degrees for 530 degrees. So it's greater than 360 degrees. So what we are going to do here is subtract 360 degrees. So that's 530 degrees minus 360 degrees equals 170 degrees. This is our answer. So one complete revolution is 360. And then because it's 530, so we need 170 more. So this one complete revolution plus 170, that's 530 degrees. And this means the angle from here to here, it's 170 degrees. Example number 8. Find a coterminal angle between 0 degrees and 360 degrees for negative 990 degrees. Because it's negative 990, what we are going to do here is just add 360. So negative 990 degrees plus 360 degrees equals negative 630 degrees. And it is still negative, so we add again 360 degrees, so that's negative 630 degrees plus 360 degrees equals negative 270 degrees. And it is still negative, we add again 360 degrees, so that's negative 270 degrees plus 360 degrees equals 90 degrees. So this is our answer. Now how do we illustrate that? So because it's negative, we move clockwise. So one complete revolution, so that's negative 360, and another one, that means negative 720. And then we have negative 270 more to make it negative 990. So this is negative 990. This angle here in standard position, which measures between 0 degrees and 360 degrees, so that measures 90 degrees. Example number 9. Find a coterminal angle between pi and 2 pi for 17 pi over 3. Now this is greater than 2 pi, so what we are going to do is subtract 2 pi. So 17 pi over 3 minus 2 pi equals 11 pi over 3. And it is still greater than 2 pi, so again we are going to subtract 2 pi. So that's 11 pi over 3 minus 2 pi, that is equal to 5 pi over 3. So this is our angle. So how do we draw that one? So 5 pi over 3 is somewhere here. This is our angle. Example number 10. Find a coterminal angle between pi and 2 pi for negative 31 pi over 6. So this is negative, so we are going to add 2 pi. So negative 31 pi over 6 plus 2 pi equals negative 19 pi over 6. Again, it's still negative, we are going to add 2 pi again. Negative 19 pi over 6 plus 2 pi equals negative 7 pi over 6. It is still negative. We add again 2 pi, so that's negative 7 pi over 6 plus 2 pi, that is equal to 5 pi over 6. Now this is a positive angle, and then it's between pi and 2 pi. So 5 pi over 6 is somewhere here. So this is our angle. Thanks for watching, guys. This is Teacher Regil. Keep safe.